to the Austin Linux meetup, and I've got these slides out on the GitHub page, along with our other page that's linked off the meetup page. And, so we've kind of got a general page that I had up earlier as information, a little more information about what we're doing, and then just I'm kind of keeping a history of our meetups and links to those slides, and if our presenters have any other content they want to put out there, we'll permanently add that along with the first slides. So look down at the bottom of this page. See, there's that's a link back to the meetup announcement for particular meetups and dates. The slides here, that intro. If we add anything else, string along some links down there with it, and maybe if we get the YouTube video up, I'll put a link there as well.
Yeah.
So more ways to find stuff. So that slides link will take you here. This is the just my intro slides for meetup, and so I guess do some introductions. I'm Darren Carpenter, and Samir is, I guess, holding the door for somebody or making sure people come in late can get in. We're sort of the lead organizers for the meetup. So if you have any questions or anything else, or want to do a presentation, or want to talk to us about anything related to the meetup, either one of us. We're getting help both from Chad over here, Chad Crowell. Crowell or Crawl?
Crawl.
Crawl, okay. And then Daria Illick, who's not here today. And we actually could use some organizational help just to lighten the load. So if you're interested in helping out, whether it's a small thing or a big thing, let us know. And let me insert a little spot of time here. And I guess, I don't know, we have anybody who's a recruiter here today or who is hiring for anything? I guess we ran into that last time too.
We're hiring.
Linux Academy's hiring. So.
linuxacademy.com/careers.
Yeah. And I know Craig's looking to hire, which is where I work as well. I don't know much of the details, and I'm not recruiting for them, but they do have our R&D presence here in Austin, and a lot of their jobs work here or work there. So if you're interested in real techie, they are a Linux-oriented shop these days. Also do a lot of hardware-oriented stuff. So if you're looking for something like that, that's a place to look.
Did you see the program?
Yeah, we've got. I mean, it's
one of the guys right there. We're looking at these programs.
We're so. I don't know the full scope of who they're looking for or what the positions are.
Okay.
But we do have. I mean, they've got kernel code device drivers. And we're I'm supporting those firmware BIOS and controller driver kind of code and stuff like that. It's all local hardware code. Whether or not they're looking developers for specifically that niche, I'm not sure. They're really looking for a variety of people. Though. I know they've got some kind of DevOps-y kind of needs. So.
Silver Labs is hiring too downtown.
Okay.
More for embedded developers. But we also do some of those.
And I guess if anyone's looking and you just want to talk about what you're looking for, I don't know if maybe somebody has some leads here can point you a direction. I was not too recently looking for jobs, so I've kind of been somewhat connected to that world. And Daria Illick is a recruiter for Austin Fraser, so she's somebody we're talking about. She does kind of cloud DevOps kind of jobs. And then I guess if there's any other announcements anybody wants to make, somebody wants to talk about before we get into the rest of the content here. Okay. So I just got pinged by another person. Her name was Dana, that I had not talked to before, but Austin Chick Tech, I've been kind of in contact with them on and off since the summer. And so they're, I'm not sure if that's readable or not. It is. So they put up a couple tweets this morning. One is that they are, since today is National STEM Day, they were just saying if you wanted to do something for that, their group has a wish list out on Amazon of things that they are looking for to help support their programs for the girls that they're running programs for. And so that's a place where you can support them. And there's another here. They extended their deadline for being a mentor, and I'll explain that in detail in a second, the 15th. So if you go on these slides, you can actually go through it. There's links to these opportunities as well. So Austin Chick Tech is, they're part of this Chick Tech organization. It's a broader national organization. And they do high school programs here in the Austin area. Support about 100 girls. They're trying to do sort of job-oriented events, workshops that girls can go to learn about technology and get familiar with the technology space. They're looking for volunteers for a whole variety of things, from running their logistics and registration behind the scenes, as well as mentoring and people to help run their workshops. And they have their big kickoff weekend coming up December 8th and 9th. They've got a bunch of programs that they're doing for that. A lot of the intent of this is that a lot of girls end up going through school and not necessarily being exposed to tech as much as they could be. And so it's not uncommon to find women who graduated from college and then somehow or another found their way into tech and realized, like, oh, I really like this and wish I'd done this in school. And it's not an uncommon problem. And so they're really trying to help kind of correct that and get girls exposed, and if they're interested in wanting to go that direction, to make that decision before they go to college. That way we can maybe level out the imbalance of men versus women in technical fields. I know our office is pretty male-centric, and the room here too. We have no women again. Or we have one. Oh, we have one today. So we're doing better than us. So specifically, they pinged me today. They have a workshop they're going to run this weekend called Build a Computer with Raspberry Pi. The guy from Red Hat who's going to be leading this, but they need volunteers to help with that. Somebody asked me about the details of what they're doing. I guess I have to refer you back to them to find out the details of exactly what they're doing with the program. But on their Amazon page, they're looking for Raspberry Pi kits. So I think they're just going to take a basic Raspberry Pi kit, set it up, and start doing either. I think it's probably kind of recommended, but you probably have a catalog of project like this. Like I said, I don't really know the details, so I guess I'm speculating here. But there is a place to volunteer, and if you go to their website, you can definitely reach out to them or you want specifics. So this is the list of sessions that they specifically pointed us to. I kind of sent out a broadcast off the meetup page, so you should have all got emails with this information in as well. Sort of the Saturday and Sunday workshop needs for these sessions specifically, and in December. And since they specifically targeted these things for us, I would assume that if you know Linux, if you're familiar with running Linux on a Raspberry Pi, then that's why they're looking at us. So, but there's also this bottom link here that'll take you to the general volunteer opportunities for the whole weekend. Includes a whole bunch of different kind of maker things and sewing and all sorts of crafts and other skills that they're running workshops on. So there's a whole list there to just check out if you're interested. So like I said, there's more details on that on the email that I sent out off the meetup page earlier today. So at this point, I guess we'll thank our two sponsors, and one is Linux Academy, and I guess that over there, and I don't know if you want to say anything real quick about.
Sure. Yeah. Does anybody not know what Linux Academy is? Cool. So we're an online learning platform. We teach Linux, DevOps, Cloud, OpenStack, Ansible, Docker, Kubernetes, lots of stuff. We're going through a pretty large course launch right now. We're releasing up to 300 different pieces of content, whether that be courses, learning activities, modules, quick little nuggets, what have you. And we're focused on security is kind of our theme of all of it. So we have a lot of Linux security courses out, so check those out. We have a lot of container security. We just released Kubernetes the hard way, which is kind of a spin off of Kelsey Hightower's guide on Kubernetes. If you're into containers, container orchestration. What else? We have live shows going on. We had one today. We'll have one next Tuesday and next Thursday. And we're giving away a free year of Linux Academy membership. And also, we have like 4 or 5 questions per live show where you could win swag or gems. Gems on our site allow you to either purchase swag or unlock different modules. We have kind of like a gamification to our site. So that's it. Thanks.
Where do we find this link?
What is that?
Where do we find the link to go find this section next week?
It's linuxacademy.com/live.
Okay.
LIVE. Yeah.
Thank you.
So then our other sponsors, O'Reilly, and Samir wants to say more detail about them specifically.
Well, basically, they've sent us a box full of books, and we'll be wrapping them away over a few months, and some swag too, which, anybody's welcome to get there. And they basically want, if anybody wants to, go to the GitHub page and is interested in registering for any of the conferences, if you go through that, there's a pretty nice discount. And they also have some other, by now they've moved beyond, so they have so many products and shows, videos and whatnot. So, just go through our link and, they'll track it and, hopefully they'll send us more stuff.
Yeah, so I think both the link in the slides as well as the link on that GitHub page are both, they're keyed with an ID that tells them that we sent you their way. And so they're helping support us by sending some goodies to raffle off. And is there a discount deal or something with their stuff as well?
Especially for conferences, the discounts can be several hundred.
Yeah, so there's some discounts associated with if you're coming from our page.
Yeah.
And let us know how that works if you have any problems too. And so I guess get to our presentations. Get moving here. Kelly Fox.
see here. Cool, okay. So I'm Kelly Fox. Just as a little background, I started using Linux probably in 92 or 93, and like with Slackware and eventually got into Fedora and Red Hat and Gentoo and all sorts of stuff, and I still use it just about every day in most of the containers. But I'm pretty excited to be presenting here today. So this talk is Pairing with the Future, and it's about maximizing the collaborative potential of your software. And so it's a set of opinions, but backed up with some data, and some suggestions are more usable than others depending on your project, or maybe depending on the language, or other constraints that you might have. But just want to go through a set of things that could be helpful. How many developers do we have here? Quite a few, okay. So whether you're a professional developer or you're a casual hacker, there's a lot of things that I think could be helpful. So code is communication across time and space. If your project or your team is big enough, or your software is important enough, your code will eventually be seen by other people. It will probably it'll probably need to be understood and changed by other people as well. So someone else, maybe even you, in 6 months' time, will need to read your code. How many of you have written something and then gone back 6 or however many months later and said, what was I thinking? Why did I do this? This doesn't work the way that I think it should. I wish I would have done it differently. So when you look at how developers spend their time, and this is from Jeff Atwood, the co-founder of Stack Overflow, from one of his blog posts from years ago. But basically, developers end up spending a lot of time understanding code. And your time spent actually creating code or fixing a bug is pretty minimal in the scheme of things. A lot of times you're doing investigation or just kind of testing things out. So what we see is that ease of change is directly correlating with ease of understanding. So comprehensible code facilitates change. And if there's no surprises in your code, it means that you end up spending less time untangling someone else's or your own logic. Something else that's kind of important to think about is that code is written for humans first and machines second. Sometimes it's hard to remember that, but from the MIT textbook from years ago, The Structure and Interpretation of Computer Programs, and it said programs must be written for people to read and only incidentally for machines to execute. So keep that in mind when you're writing code. It's very easy to not think about that so much. You're focused so much on making the machine do what you want. But it's really you're writing code for yourself and for the other people that will possibly see it later. So here's another thing to think about. Projects can be started quickly, but are harder to finish quickly. Clean code matters. So as you add features, the complexity increases in your project or code, and often so does the time you spend debugging or adding new features. So what do you need to do? One of the things you can do is try to cache your context. So what I mean by this is you need to look for ways to preserve the thought, context, and process that you had at the time that you were writing this. And so I have some suggestions. And like I said, they're suggestions, they're not rules. And sometimes there are going to be exceptions. But in general, I found like some of these points that I'm going to talk about this evening are helpful to consider, if nothing else. And
essentially, it's helping you look at your code with an eye to the future. So let's talk about project, file, and function structure. So first, this background image, that's actually an image from JPL and NASA. It's the orbits of the Cassini probe around Saturn. That's Saturn in the middle there. And I just thought that was really cool, but made me think about organizing, how much organization had to go into making that happen the way that, I assume that they meant for it to do all that, and that wasn't just an accident. So some general approaches to project organization, like generally want to follow the conventions for your language or framework. Sometimes there are some, sometimes there aren't. Depends on what you're working with. Otherwise, like trying to arrange the folders, like you have more abstract things and then subfolders are more specific. Perhaps you should organize your code by features or functionality. And overall, if you try to keep your code close together, the pieces that interact frequently, if it's easy to find the files, then it's easier to make the changes. By the way, if anyone has questions, you can ask me anytime. Just throw your hand up. Also, please save your derogatory remarks for the very end so that I can feel them all at once. Okay, so general file layout. This is what I've found to be pretty helpful. So you have imports first. So usually like built-in, external, and then internal imports. Then you have like common variables that might be, if you have them, common to the entire file. And then function, class definitions, preferably before they are invoked, so you see what the definition is before you actually refer to that later. And then if you have any main program logic, and then any exports. So in a function or method, you kind of follow a similar pattern. So like variable declarations, then you have possibly an early return if you have a very complex or expensive function to execute. If you can do an early return, like do an if statement, something like that. But only if it's a very expensive function and you can do that. Oops, excuse me. Then you have core function logic and then your return. And then blank lines as needed. I mean, there's a lot of these things get into preference, subjective kind of judgments, but it does help when there's a visual separation between these chunks sometimes for your eye to jump to the next section. So sizing, just very briefly, and this is, there's a lot of different things to say about this, but in general, if you can try to keep a function or method like within 10 lines, and depending on the language, it could be more or less. Like in Ruby, typically a lot of Rubyists try to keep their functions to like 4 or less. But some languages are much more verbose, and it's harder to do that. But the whole goal of all of these is, like I said, to make it more comprehensible. So anything you can do to minimize scrolling and jumping around visually is beneficial.
So your files, basically, piece of code, you guide to total page?
That's what I aim for. It's, like I said, it's not always possible. But what you can do in a lot of cases, let's say if you're working on a modern web application, there are various bundling tools that will transpile, compile your code in such a way that it doesn't matter how many source files you have. And if you have individual files, like in runtime, it doesn't matter how small or big the files are. So if it's easier for you to isolate the logic in 2 pages, less than 2 pages, then do that. If you can. If you can't, if it's like a really cumbersome thing, then maybe you do need to make it longer. But you should also ask yourself, do I need to refactor? Is there a reason why it doesn't have to be this?
Or just switch to the legal side?
Yeah, yeah, exactly. Yeah, turn your monitor sideways so that you can. All right, so good functions and methods, and this is a little XKCD comic that enjoyed. So, how do you write good functions and methods? So, here's some tips. First, functions should do one thing and do it really, really well. Try to write pure functions, so when you give it consistent inputs, you should always get the same outputs. Try not to share state between functions, especially if you're dealing with asynchronous code. You can run into issues that way. And also avoid changing state. You can break code elsewhere if you change state in your function, once again, especially if you have asynchronous code. And then try not to have any side effects, so nothing else should happen when you execute this function, except returning the return value. So, briefly talking about arity, which is the number of arguments to a function. Try to keep that low, because it's really hard to remember the order of arguments to a function, and it tends to make you go back and look and double check, okay, am I doing, did I swap argument order? And so, like, if you can keep it short, it's much easier to remember. If you do need to pass a lot of arguments, especially if it's a variable number of arguments, and sometimes you can pass some sort of options object or structure that has a variable number of properties. And then that takes care of needing to know exactly what order things need to go in. And usually you put that as the last function. There's only two hard things in computer science: cache invalidation and naming things. This is attributed by some to Phil Carlton, but I couldn't really find a definite attribution, but it's something that gets thrown around a lot, and naming is a difficult thing. So when you can, try to pick obvious names for things. So I was looking at the Linux kernel style guide, and they recommend, like for temp variables, TMP, they have a set of recommendations. And you would take that into account. If you're working in the kernel, you would want to look at their style guide definitely, or else your pull request is going to get rejected. Yeah, ignored, rejected. But yeah, when you can, try to pick obvious names for things. And so ultimately, if you can make your code read like a story, then that's going to be beneficial. Because another human, like I said, maybe you're going to read it later, someone's going to read it later, and humans are attuned naturally to storytelling. And you'll pick up on that if you can make your code tell a story. And how it tells a story is up to you. And once again, it depends on what language you're using. Some languages are easier to do this with than others. Like Java, there's a lot of boilerplate and verbosity. The variable and function and class names are generally highly descriptive, maybe overly descriptive, but it's easier to tell what they're doing. And it's okay if you use long names, especially modern IDEs let you autocomplete most of the time, so it's not such a bad thing. And then if you end up using things like some number in your code, like the number 4095, so what does that represent? It could represent like some multiple of bytes, or it could represent something else entirely, but you should probably just assign that to some variable and then substitute that variable everywhere that you need to use that, so that it's very clear what that number is doing, what purpose it's serving, why you're using that. Comments. Program I coded has lots of bugs. How do I remove them? Why don't you put the entire code in comments? Sometimes I've done that to troubleshoot things. I don't know about you. So here's where you should use comments where they're useful. So like API documentation, sometimes it's like, if you've seen this at the beginning of functions, like Java Doc uses this, JS Doc, Swagger, various tools that automatically like generate API documentation for your classes, methods, and functions. Any linter directives, obviously, if you need to use that sort of thing. Any curious code that you have to write for not obvious reasons, like for a known bug or an API that's kind of wonky. Like if you have reservations about adding the code, then you might add some sort of comment that says, this is why I'm doing it. I know it's ugly. You may not have to say, I know it's ugly, but it's kind of implied. And then if you need to illustrate the program flow or data handling in samples for beginners, or you're trying to show off some functionality to someone else. But usually they're superfluous. If you're trying to describe normal functionality, your code should do that. Or complex functionality, refactor your code instead. It means your code is too complex, probably. If you're just trying to prevent code from being executed, then it's okay, like I said, for temporary debugging, but just delete it if you don't need it anymore. If you think you need to keep it around, you probably don't. If you're using any kind of version control system, Git or anything else out there, there are ways to get the history back, previous versions of things back, and you should take advantage of that. Delete aggressively. If you have code that's dead, remove it so that you don't have to think about it. And then if you have to-dos or other changes, like I need to do this later, use a real issue tracking system or put it in an external document, something that that you can refer to later. It's code or comments usually have this problem where they're difficult to maintain over time. They don't usually keep up very well with the actual code that they were linked to, so people end up making changes, especially with a long-lived project. So, and people don't always delete comments or update them. So, refactoring, and I intentionally made that in split lines. But that's what it feels like sometimes to refactor code. But there's a lot of different reasons why you might try to refactor your code. So one reason is dryness, and dry is an acronym that means don't repeat yourself. So essentially you want to extract patterns that are repetitive from your code into some sort of helper function. That way you don't have the same boilerplate over and over again. If you have common constants, you can define those in a shared file that you can then import in multiple files. And then you don't want to overgeneralize things, so try to use inheritance or composition or partitioning, different things to make it so you're not repeating code. Sometimes, I have to say, as a counterpoint to this, it's useful to have repetition of code if you can abstract too far. Any of these things you can take too far. So a lot of this has to do with judging what is right for your project, comparing it to other maybe similar projects or code. So another reason to refactor is simplicity. Like you don't want to nest a lot of code. If your code has nested for statements, for instance, then you might want to consider factoring out some of those inner nests to functions, and then just call those functions. Then don't code cleverly, because it often conceals the true functionality. Unless you need high performance or you're doing a coding challenge, code golf or something like that, you usually shouldn't try to write cleverly. It just ends up confusing people, and like I said, it makes
How do
it...
you define clever code?
Well, it's...
Elaborate on that a little bit?
Yeah, so...
I got an example, I'm just curious. It's like, if, then, else, and then
Yeah, so
some
like
people leave the if and the then out, and there's the braces, and,
right,
and that's real hard to read.
if you're doing something
Is that what you mean?
yeah, that could be one reason or I don't know that that's necessarily clever. There's some things you can do in various languages that take advantage of some quirk or behavior, maybe even a side effect of some other capability within a language. And if you're doing that and you don't have a really good reason why you're doing that, don't do it. Like if you learn this new technique and you think, okay, I'm going to use this because it's cool, don't, because it's going to, like I said, unless you're doing something for performance reasons or for a challenge, it makes it difficult to understand and debug later. So clarity is another reason. So once again, you want to limit your functions or methods to one purpose. Think about moving your any kind of transformational code into separate functions. And by that, so if you have code that just does some sort of transformation, often you'll have a series of maybe transformations that you're doing on data. You may want to move one step of that. Instead of having a huge long function with, do this, do this, do this, you might take one chunk of that functionality and put it into a separate function, or all the chunks of functionality and put it into appropriately named functions, like remove spaces from string, or whatever. Depends on what it is that you're doing. Also, sometimes one-line functions are great. Like they're really descriptive, and especially if you find the need to reuse them, that same kind of logic elsewhere. And if it's not entirely clear, it could be a series of transformations, just maybe even short transformations. But if you were thinking about it as someone new to the code base, and they saw this thing over and over again, like, would it have the same meaning to them that it does to you? And if the answer is no, then consider extracting it to a function that has a better name, so that it's easy to see exactly what's going on. And once again, the magic numbers and strings, use meaningful constants so that people understand what those are about. And then, as I said, use more verbosity if you need to, and if performance isn't impacted. So another reason, last reason that I have for refactoring is testability. Sometimes, often, predictability improves testability. So once again, if your functions have a consistent input and output and only have one purpose, then it makes it easier to test that. And then when I say only advertise what you need to test, like only expose or export the things from your class or your file that you expect to be tested or to be used by something outside of that file. Don't just export something because you might want to use it later. If you don't know that you need to, then you don't. Also, any configuration, try to extract that into something like a file, a database, or environment variables. And then here's something else, don't test other people's code. If you're using a third-party library, you can assume that it probably has tests. You can look in their repository if you want to check that out. If it's a GitHub repo, for instance, check that out, run the test suite until you're confident that it works the way it's supposed to work. Don't write tests to test that it works the way that it's supposed to work in your code, because it's redundant. And you should be testing your own functionality, the things that you do. And then if you need to use dependency injection to simplify testing of external services or complex objects. So sometimes you might inject a config object like throughout your the whole code path, so that you can test things in isolation and vary the configuration for each test. So safety nets. What I mean by that are things that keep you from shooting yourself in the foot, or for promoting bad code production. And obviously testing is one way to do that. And if a test is written well, and to be clear, it's not always appropriate to write a test, and it's not always possible or feasible. But if you do have tests, they can explain how your code works without having to look at the code itself. It should explain the functionality, and it should be very clear what the code under test should be doing. And just test what you need to test. And if there's bad tests, sometimes that is more harmful than good. So consider even deleting some tests if they're not doing what they should do. And then if you can do automated testing, that's awesome. Not every environment lends itself to that. But just in your own personal development environment, if you can set up some sort of tool to watch files, watch changes, there's, let's see, what is it, the FS events in the Linux kernel that watches, you can hook into that and trigger off file changes. And there's various tools that watch and can hook into that and run some command based on the change. So use those so that like code gets recompiled automatically, maybe redeployed to some local server or something so you can test it immediately. And if you can, use continuous integration service that will automatically execute your test suites after you commit to your repository. So another thing, obviously source control. Try to work, there's a method called git flow. Not everyone subscribes to it, but essentially when you're using git, one of the methods that you use is you create a feature branch. So a branch that you work in to test or add a new feature, and then you end up testing everything there, and then you do a pull request. You try to merge that in, and so like it doesn't. You're not working off of the master branch. Then another thing you can do is to just make a lot of commits, so that you have backups, your own backups. So if you're committing frequently to your own little feature branch, you can collapse those commits later using a rebase command. Also use some meaningful commit messages to help remind you what you're looking for. And just try to learn the tools really well. The Git has a lot of functionality. And all the source control tools do have some amazing capabilities. Another thing about if you're using third-party APIs, you might consider wrapping them in some sort of generalized wrapper. What this does is it lets you swap out some underlying service with minimal changes to the rest of your code base. So like if you change databases from Postgres to MySQL or something else entirely, it would be a minimal impact. Documentation is obviously something. There's sometimes in JavaScript projects, node projects, or like React or various things, there's usually a package.json file. Other things like makefiles might also be a good substitute. But if it's not really obvious what the functionality is or what you should do to get the environment up and running or tested, then write a separate README. And if your code is well written and your tests are well written, then you might not need as extensive documentation as you might otherwise. So on the subject of continuous improvement, there are things you can do to help ensure your success. You can use linters to help catch errors as you type. And if you don't want to do that, if you don't have an IDE that does that, you run it after the fact, prior to committing the code. You can use various beautifiers to make sure your code is formatted. In the Linux kernel source, there's what is it called, L script or something to that effect, that will format everything to the Linux style guide standard. So it's very important for most projects. And then your IDE can use syntax highlighting, so make sure you enable that. And static type checking. Like some languages have that already, some don't. But if you have it as an option, it can help with auto-completion and all sorts of other handy things. Then when you're choosing a new tool or a framework, try to keep an open mind. Popularity doesn't necessarily equate to success. React might not be the best front-end solution for you. You need to think about what the problem is you're trying to solve. And obviously read books, blogs, listen to podcasts, etc. So some of the resources I use to compile some of these suggestions. There's a few books, Clean Code by Robert Martin, Code Complete by Steve McConnell. And Pragmatic Programmer has been around for a while. It's a really good one by Andrew Hunt and David Thomas. There's a podcast that I've kind of listened to off and on, Hansel Minutes. He talks to a lot of different people about just the craft of coding. And then I really like Sandy Metz as an instructor and developer. She has some pretty interesting things to say on maintaining code. So writing maintainable code and software is an art. So you can learn to code quickly, but like any technical or artistic endeavor, it takes practice to perfect. So I hope that you practice and think about some of these things next time you're working on a project. Any questions?
So actually some comments. One thing you probably would mention is namespace collisions, software, make sure you're not naming the same function or global symbol, which would collide something else.
Yeah, that's an excellent point.
In terms of like documentation, is it DocsGen for like C or Python projects?
Yeah, like I tried to make this somewhat generic, and I didn't want to list all the tools, right? But yeah, there are, just to be clear, there's a lot of other tools out there for different. Yeah. But yeah, it's an excellent point about the namespacing and just keeping in mind what your don't use the same name in multiple places unless it is the same thing.
Yeah, just as an example, I was trying to integrate a library which had a function called start timer, and this one in its kernel, which collided with. And this kernel is start timer, stop timer.
Yeah,
Interesting
great example. Any other questions or comments?
In the safety nets section, you talked about adding wrappers, the libraries and stuff. Do you always do that as a general rule, or only if you really know that you're going to be maybe swapping things out?
I don't necessarily start off with that. It kind of depends on the project, but often that's something that you might build in as your project grows a little bit. But like starting off from scratch, I generally don't. I don't try to over-engineer, right? Like there's a lot of things that you could do initially, but you probably shouldn't quite yet. But if you're in the process of doing like evaluations of things and you know that it may be switched out at some point, or like maybe one example might be your cloud service provider. Like if you're using Amazon Web Services, it's really easy to get locked into that if you use all of their SDKs and they want that. And if you want to consider other options, you might write some kind of light wrapper, your own abstracted layer on top of whatever the SDK calls that you are making. Because there's going to be something similar in each cloud provider's SDK. But yeah, so I don't start off with that to answer your question.
Yeah, I worked in an environment where that was the rule, is you had to have a wrapper, and sometimes it felt like a waste because you had to import a library with this nice API,
Yeah.
and you write your own very short.
Yeah, all of these things can be overkill, and so that's why I added many caveats along the way. It just, you kind of have to think about how the code is going to be used and what might be likely to change, and maybe what the biggest pain points might be, whether it's the cost of a cloud service or it's the complexity of some third-party software. So, yeah.
Are there any semantic linting rules, basically things that do more than syntactic construct checking? Essentially, like those would be like the first pass, to allow, say, code review to get through the syntactic checks. And then you could probably say that, I don't know, like in the past there used to be these, cyclometric complexity and those types of things.
Yes, yeah. So there are ways, and it depends on the language you're using. Some tools might be easier to come by than others. But like in Python, for instance, there are ways. I can't remember if Flake 8 does it or not, but there are tools to check cyclomatic complexity, and so that's that's the basic complexity of your code, like how deep your nested for loops are, for instance, that sort of thing. And the higher the complexity, the more difficult to change and maintain. So trying to keep a low cyclomatic complexity is good. So if you can find tools, just like looking at what your tools can do first, it is a beneficial first step. So look at there's linters for just about every language and other tools that you might be able to find that are similar. So and like I like to look on GitHub at the awesome lists. Have you anyone seen these? You know what I'm talking about? So some people are nodding. Basically, people have started, I don't know who started it, but there are folks who created a Git repo that is just a list of awesome things related to some subject. So if you just in Google put awesome C# linter, something like that, then you might find, or just awesome C# even, GitHub, then you might find a list of things that or C# specific things on a list of things on GitHub. And so like finding, that's sometimes one of the ways that I find other tools and just newsletters, and that's why I suggested podcasts and newsletters and et cetera, because people talk about things and sometimes it's just in passing that you might hear it, but it's often worth looking at to see if it's going to be beneficial to your workflow.
Number of characters in a line?
So I didn't address that, but I could. And my personal preference is I like the 80 character limit.
Cool.
Just because it's easier. It's often easier for people to read. If you notice, a newspaper or magazine article often has multiple columns. And if any of you have seen newspapers or magazines, they're mostly that way. But they usually have multiple columns, and that's because it's much easier for your eyes to scan vertically than it is to wrap around, and you sometimes lose where you should align, where the next line actually is. And so you spend more cognitive effort, and that adds more friction, and that slows you down as a developer. So
tab stop then?
So I think that varies because it depends on the language that you use. Like Python has has to be four spaces, and then like make-files have a specific number of tabs. And you have to use tabs and not spaces. And then like the Linux kernel stores, you have to use an 8-space tab. And like other languages, I'm often fine with just 2, but it depends on how complex your code is. Like languages like Ruby, where you can be slightly less verbose, it's easier to read and follow the indentations. But what the indentation can do is force you to keep the cyclomatic complexity low, for one, because if you're indenting, you're probably doing a loop within a loop within a loop, or something of that nature, and you probably want to consider refactoring in that case. So it's like, you need to look at the norms for the language that you're using for the most part. Other questions?
One more, which is like a contentious topic, but
Good.
more issue in terms of, especially if you're like, kind of a new company or like, small team and trying to, not run into minefields. Is it a good idea to say even prohibit certain language constructs and, even have maybe your automated ways of, that something won't be compiled or
I would say yes, because sometimes those are specific to the style of a project. Like whether when you're doing an if statement, if you put the opening brace, curly brace on the next line or at the end of the line with the if statement. But those sorts of things those are often project dependent, but it's also language dependent. And sometimes you want to make sure that it's consistent. So for readability, or for if someone else comes in and uses a tool that auto formats, like ideally you would use some sort of linter or beautifier that makes the code consistent, and you don't have to think too much about it. But those you do need to have the discussions with your coworkers. If you have the ability to help make decisions, then have those discussions and figure out what's appropriate for this language or for this type of framework, and should we block some of the functionality, or there are some things in various languages that have been deemed as not as creative an idea as they were once thought to be. Like Python deprecated a lot of things over time, and various other languages have done the same thing. And while they might still be supported, you might not want to use them because the functionality, the underlying functionality might be slightly different, or they may actually be in the process of removing that from the language. There's a lot of reasons to not use particular things that a language makes available. Yeah.
Rule of thumb that we use is if you can tell who wrote the code, then something's wrong.
Yeah. If it's so stylistic that you can tell, then it's probably not good. Yeah. One other last parting comment is that you should always write code as if, you may have heard this before, write code as if the next person to look at it is a psychopath who has your home address. And that helps to make sure that you follow all the rules that you should be following and do things that make it comprehensible. All right, thank you very much.
Okay, basically, this is, I can't see forward that far. This is a method that I use that I kind of invented to basically put version control information in file. I've been using Unix for a long time. If you do Git, and this was the frustrating piece I had, where I have about 24 systems, and what version do I have on all my systems? And when I did a lot of consulting, a lot of customers had the same problems. This is just my method. I don't know if you follow all his rules or guidance. Basically, my goal was this. Basically, if you don't know anything about the tools I use, or Git, or GitHub, or anything, you're giving them a product, I want to be able to pick up the phone anywhere in the world and call them and say, what version are you running? And so this was a method that I used to solve that problem for my stuff. It basically is a wrapper, and slow me down or speed me up or interrupt me because I might end up going too fast or too slow for some people. Basically, it's just a wrapper around these three commands: git, add, commit, and push. I wrote it to support multiple files. It just looks at the extension on the file and then adds a comment in the second, and the third line. And basically, this is a standard graphic about it, going from the bottom up. Git, add, commit, and push. I developed it. It's on GitHub, and someone came back and said, "Oh, it doesn't work for GitLab." And I thought about it. I thought it would work. I had to make 7 changes, and 6 of the changes were just in comments and documentation. Instead of making really one code change to work, because I'm not really doing too much fancy stuff. I just wanted to enter these 3 commands. Okay. And so I call it Market. Basically, all you need is a repository on GitHub, GitLab, and you need to be in that directory structure. And you edit a file, you push it up. So if that's have a little more, but I'll show you how it works. Okay, we're just going to go into the directory here. These are the extensions it supports currently. I'm not compiling code, so I didn't write the functions to deal with compiled code, but it's pretty easy to file. So here's basically a script. And any comment, I just modify it. And so it asks you tells you what version the current release is that you're using. Prompts you like that. You can use the same number or you can increment it. It asks you for the comment, basically for the commit. Whatever you want to put in there. And I practice this and there, so it's not prompting me for a password, but it would prompt you for a password. And then now that changes up on the repository on GitHub. There's a lot of misses happening. Basically, this is the line it puts in the code. Again, any one of those styles and stuff, it's just all I'm doing is putting 2 lines of comments. Mark it is the name of the script, but it's also whatever your piece of code is. What I highlighted was the current version, timestamp. I modified this as I've been using this over the last year to solve different problems for me. I wanted to be able to have enough information to know what version it is, but also what repository did I put it in and which subdirectory in that repository I put it in, so I kind of had to tweak it a couple times. Solve all those questions. When I finished it, I decided I needed another piece of code called check market because I have, like I said, 24 systems, and I wanted to quickly know, am I running the latest version? So I demonstrate that check market basically. I'm going to go ahead and check. So basically what it did is it just went up to the repository and said, here's the current release that I identified with the -F option. And it went to the repository and tells you what version is on GitHub or GitLab. And those are the, of course, we just edited in this version. Okay. Then another thing, I was messing around with my 24 systems, like, oh gosh, where are my repository? So I'm working on this last little script. These are just small shell scripts, defining what work I'm doing on which system. And that's pretty much, again, this is just a sample of code that we just did. And thank you. Now let me show you a couple more things. All right. I'm a little older than most of y'all, so I seem to somehow get a few things. So it supports help. I mean, if you want minus help or whatever. basically it has, so if you forget or wonder what this little script does, and that's a little document. It talks about the basic syntax, short description, and how you handle different files. I only handle tracked files. I added this option to handle tracked and untracked. I like to leave some untracked because I don't want to check them in while I'm working on different things. So I have this particular function. Question? Like crickets and. That's it. Jameer, did you have anything to add?
Well, all I know is that there used to be $ID, $type macros and, RCS, SCCS in the past.
Yeah, I used those.
When these things were suggested, Linus Torvalds, was the original Git author, and others were completely, scornful of the idea. So I'm just wondering,
Oh,
what
yeah.
might be the caveats there?
Yeah, I mean, when he started writing Linux, he had a pretty blunt attitude, and he's writing it for the kernel, so comments really don't work real well in that. And he had a strong bias. I think you can go online and see a video where he kind of curses out several people in the audience, things of that sort. Literally. I'm not writing on the kernel. I need the information in the files to verify what version I'm running. I don't want to go back to GitHub and go figure it out and all that stuff. So, not really caring what Linus has to say about that. Matter of fact, he's on a sabbatical right now because the last time he took a sabbatical, he wrote Git to solve the particular problem. So he's on a sabbatical right now to, I think there's a video about that too, about adjust his attitude or do other things in life. It was amazing when he announced this. AT&T owned Unix back then, and he was against the big guy in town, and then he sold it to another company, and another company, and another company. And I used to do a lot of consulting here and work for a lot of researchers here in town, and no one really believed he would be successful because, how could he sustain others? And now everyone seems to use his. Did that help you?
Yeah.
Yeah. And then you looked at my code. Do you have any comments about that?
I mean, if you want to, maybe you can pull it up.
It's just a shell script. I'll be happy to if there's still interest. Again, they're basically a couple lines of comments. Sometimes I delete the comments out after I'm making the next change to it. Sometimes I don't. And there's a little comment right here about what you just asked. It's right down here. This is released files need a version number in the text when I check it in. This is not for your kernel. It's basically to Linus. It's just a file, so fight me and merge that. So basically, that's probably, I should have responded to your comment like that. All my scripts, pretty much I have a debug statement, it's right there. I'm changing this so that I can set this with an environmental variable, so I don't have to edit the script. I assume sometimes people may not have permission to edit the script, but if you have problems, just set it to 1, run it, it'll give you a lot of debugging information to figure out, and pretty much all the debugging in there is when I was building it, it's this didn't work, I'm in the wrong directory, things of that sort. So I just went ahead and put a little line. The first function here is basically just to help. Just a bunch of echo statements, basically it's all code that we just saw. I put a little section down here, basically to support multiple languages in the future if I need to. And then these are just like several functions. I have a date function, post, version, GUID, things of that sort. I wrote it to, again, to solve different problems that I'm working on. I have stacks of systems, and I also have Raspberry Pis, several clusters of those. And so I'm running different software on each one of them, and I have information going to the log. This format helps me solve that. Basically, it's the date, it's the first one, so I can merge all these logs into one and sort of. I did do a couple things he suggested. I tried to space each logical grouping. I did exceed the lines, but most of this is basically just like this is a this one here. This is information that will pop out. I commented to each section so I don't have to go back and figure this stuff out. 6 months down the road or 6 days down the road, sometimes you can't remember what the heck you did.
I had a question, I guess.
Yeah.
I guess it could also be written in the form of a hook. So a hook in Git, so that automatically, if that was in the hooks, using the standard Git commands, it would run the script before you did the commit, and then do the commit behind the scenes.
I'm not following you though.
You can specify a
Like-
pre-commit or whatever type
Yeah,
of hook that
yeah.
automatically would invoke a script or something.
Yeah, I just wanted to, there's, like I said, this is just the method I came up with. I just wanted to stick with this 3 commands in Git. This is kind of the way I solved that particular problem and get tired of typing all that good stuff. And my goal was, again, just to have the version in every file. So there's many different ways you can go in here and change the wrapper and have like a back end before it gets pushed or run kind of some kind of test or, whatever you want to do. So I just chose this particular, that's why the first slide, this is just a method that I chose. And I don't know, not sure anyone wants to read all this, but basically, any more questions? I mean, I don't want to read line by line to y'all.
In your compile language, how do you put the version information in there?
Basically, way back when, you said, I don't have any compiled code, so I didn't write that section, but I have an understanding of how I wanted to do it. And basically, I would define certain variables certain variables that wouldn't be ripped out.
Yeah, because I know one of the products I worked on is pretty complicated. A lot of library. It's really useful to have. We actually had in our code headers on open source code files.
Yeah.
A CCS header that would do static and variable name that corresponded to the file name and the source code.
%W,
And then
percent
the
R,
version number. So we could
Yeah.
we could correlate from a running system. You
Yeah.
run strings on a library and find out exactly which version of each source file.
That is correct. Yeah, I'm glad someone knows it. Basically, we would run the what command back then. I don't think they have the what command in Linux anymore, but what would pretty much do the string command and go find that particular string and just spit that out, which would have the version on it.
That was super helpful for us.
Yeah. So that's the direction I came from. It's like, get miles and miles and miles of code. Basically,
We put them in kernel modules too.
yeah. Yeah, but back then
In
we do
Linux.
%W, there was like 3 or 4 different variables you would use or characters. And then SCCS or RCS would convert those
Yeah.
into a different format, and then the compiler would handle it too.
We had just a standard in the software area that I worked. every C file had this header on it, and then the version control will take care of the rest. And the same with header files and C++. The standard language. And shell scripts as well.
Now, I only use this, I'm the only guy working on my project. You know, I don't have to share, deal with merge. Actually, I do have to deal with merge because sometimes I'm on two machines and I forgot to get rid of the old ones. But I've never tested with multiple users, things like that. Branches off the master. I'm working on the master, breaking all those rules, but I'm the only guy working on the code.
Yeah.
So I don't see any reason to have a branch because I don't need to talk to anyone to merge it in. It's myself. So this is basically this is how I handle the different versions and what comment characters each type of extension would use. And so this is how I supported multiple scripts and tools and things of that sort. That's all it does is a beginning comment, and not all of them require an ending comment, you know, like a shell script. You just begin at a pound sign, but some others do, and so it's pretty much the way I handled all of that. It took about a couple of months to spare time to finish it all, and then I've been using this, I guess, for over a year now, and each time I can tweak it a little more, Again, the next thing I want to do is be able to set the environmental variable for debug versus having to change it from 0 to 1. And here's the push statement right here. It does look like that. And if it errors out, it spits out this message at the end. So if this get push fails, it basically just prints out all this information. It tells me either fat fingered my password or something else. I'm not in the directory, things like that. And then I have two pushes. One is like you need one just when, like it's your first push to your GitHub account, and then the other ones are just one time you choose not to use a particular new version number and you use the same version number, it uses the same. Again, I'd be interested if anyone wanted to try it. I'd be interested in your comments on it. That's all I got. Now on the slides, I did put, because when you started this a couple of weeks ago or months ago, some of the people were new to Linux and Unix and some people were old. So at the bottom of my slides, basically are the instructions. If you walk through, you know, I'm just using the instructions off my account on GitHub, but you can clone it and or fork it to your repository, download it, and modify it. So I put some steps in here for people that weren't real familiar with it. On the bottom of these slides, basically how to go through it. And then at the end, I went ahead and put basically, you know, source code. And then these are my rough notes when I wrote all this stuff a while back, about a year ago. So anytime I do stuff, I try to make some notes. They're, just consider them like written on a cocktail napkin, you know. They're not like formal documentation, but enough to kind of work you through this particular, understand how I set up Git and things of that sort, how I configured it, things of, you know, use the .git config directory, that's how I set up SSH, HTTPS. The reason I always like to write stuff down, not because I like to write, because when you set up your account, or when you do something, normally you have to do it once. And you may have done it 5 years ago, or 5 days ago, or last year, or 6 months ago, and then all of a sudden I chose to get another GitHub account or something. So it's just helpful for me to write it down, especially anything I have to only do once or twice. Like I said, I have 24 systems, and inevitably I reload operating systems, things of that sort. I'm a systems background. I've built data centers, moved data centers. I've owned my own software development company. I've managed people all over the world and things of that sort. So that's all I got. I've just put those at the end in case someone was interested in how I got there. That's all I got.
So, I guess I'm not 100% sure. Is this about what our agenda is for next month? Or we sorted that out yet? Or where are we on the agenda for next month?
Well, I mean, that's the second one, the months talk is there, and what is the idea of doing lightning talks? So, especially given that December, you don't want to go to deep, heavy topic.
Yeah, so I guess last month I kind of put a little more in there just to open it up for anybody as far as if there's interest in doing lightning talks, we can do that. Or we can do some sort of other either open discussion or more organized structured discussion, coffee talks, something like that, if people are interested. We wanted to keep it kind of light for December. So if you have any input on that, we'd love to hear. And we do have one presentation that's tentatively lined up for December. And if somebody's dying to present something or has something interesting, we'd love to hear you too, and either short, long, and we'd also like to keep the schedule forward full too. So if you have a bigger talk, January, February in the next year, let us know.
We might even be flexible with lightning talk time because they're pretty strict at like cloud hosting. You don't get a second over 5 minutes. We can do 5 to 10 minutes.
Get a box and down.
Nobody will be wrapping your knuckles if you go over 5.
So that's about all I have here. So yeah, let's go back to